Okay guys, today section 3.2 operations with matrices. Today we're going to add matrices, we're going to subtract matrices, and we're going to multiply them by a scalar. And we'll talk about what all that stuff means piece by piece. Okay, so adding two matrices. Okay, so when you add two matrices, they must have the same dimensions. They got to be the same size, same number of rows, same number of columns. And to add two matrices, once you make sure they have the same number of columns, you simply add corresponding elements. Okay, so looking right here, we would add the 5 and the -2. Let's just make five and a -2 is 3. All right, let's do a -3 and a 1 is -2. -3 and 3 is 0. 4 and 0 is 4. Let's do 0 and 4, which is 4. Let's go to our pencil. 7 and -3 is 4. And that's all you got to do. Super easy. Okay? The new resulting matrices has the same dimensions as the two matrices being added. Okay, so when you're adding them, it's just going to keep it the same. Okay. All right. So let's do some examples here. I'm going to do one here and one down here. All right. So this one, the first row is going to be 8, 0, -1, 3. Second row is going to be -5, 4, 2, 9. We're going to add it to first row is -1, 7, 5, -2. Second row is 5, 3, 3, -2. Okay, and then the answer to this one, 8 and -1 is 7, 0 and 7 is 7, -1 and 5 is 4, 3, and that should be a +2 right here. I did not copy that down right. Let's try that. I got a little excited. 3 and 2 is 5. -5 and 5 is 0. 4 and 3 is 7. 2 and 3 is 5. 9 and -2 is 7. Easy peasy. Okay, let's look at the next one. Three, -4 is the first row. 0, 2 is the second row. We're going to add that to first row is 4, 6, 8. Second row is 0, 2, 4. Now, when you look at this, you're going to say, hey, these are not the same size, so we cannot add them. So we cannot add because they are different dimensions. So this is going to be undefined. Okay, you can't do that. All right. All right, let's look at subtracting two matrices. To subtract two matrices, they must have the same dimensions. We just have to be careful because we're subtracting them, so it's like we're changing the sign of the second one. Okay, we'll look at it in just a minute. So to subtract, simply subtract corresponding elements. All right, so here's our problem. We're going to do two problems. We're going to do one here and one here. So we have a 9, a -2, and a 4. A 5, a 0, and a 6, and a 1, a 3, and an 8. Minus 4, a 0, a 7, a 1, a 5, a -4, a -2, a 3, and a 2. Now, 9 minus 4. So one way you can do this, it's super simple when they're both positive because you just do 9 minus 4. But what if this were negative? Then you would really change this to, if this were -4, it'd be 9 and a +4. Okay, so you look at this as 9 and a -4, so that's going to give me a 5. Okay, -2 minus a 0 is a -2. A 4 minus 7, so a 4 and a -7 give me a -3. A 5 and a 1. 5 minus 1 is 4. And then 0 minus 5 is -5. Then we can do, let's do this, 6 minus -4. When you have minus and minus, it becomes a plus. So 6 and 4 is 10. All right. 1 minus -2, so that becomes a +2. So 1 and a +2 become 3. A 3 minus 3 is 0. And then an 8 minus 2 is a 6. Okay? Okay, next problem. you have a 2, a negative 4, 3, 8, 0, negative 7, 1, 5, 0. So this one's a 3 by 3 minus first row 0, 1, 8, second row 3, negative 1, 1, next row negative 4, 2, 7. Okay, I want you to pause it and I want you to try this problem. Okay, so pause it and try this problem. Alright, so if you paused it and worked this problem, I'm going to write out these answers and then we'll talk through them very, very briefly. So this is what you should have got. So 2 minus 0 is 2. Negative 4 minus 1 is negative 5, because that becomes a negative 1. 3 minus 8, so 3 and a negative 8 become negative 5. 8 and a negative 3 is 5. 0 and a positive 1 become 1. 7 and a negative 1 become negative 8. 1 and this becomes a positive 4, become 5. 5 and this becomes a negative 2, become 3. 0, this becomes negative 7, becomes negative 7. All right. Now, let's look at an application of this. All right. So take a minute and read over this. So pause it and read over this problem. Okay, so you've had a minute to look at this, and it's looking at the National League's batting leaders for 2003, and that was Albert Pujols, I can't remember, I think it's Todd Helton, and Barry Bonds. Okay, and you're looking at their at-bats, their runs, their hits, their home runs, their RBIs, which is runs batted in, and their batting average. And for those of you that are not sports people, the .359 means that Pujols hit the ball 35.9% of the time he was at bat. And I mean, like, that's pretty good. I know you might not think it's pretty good, but that's pretty good. Okay, the following statistics for the same three players show at the end of the 2004. So you're looking at the changes from one season to the other. So you want to find and label a matrix that displays the changes. So therefore, we're going to subtract the two in these statistics from 2003 to 2004. So you want the most recent minus the oldest. So you might want to pause this, but you're going to take this basic matrix and subtract this matrix. Okay, so if you want to pause it and copy this down, then when you do that, you're going to get this. Okay, notice that several of the statistics decrease. How will you show that in your matrix? Is by negative numbers. Okay, so Pujols actually increased his at-bats by 1 in the 2004 season, but his runs decreased by 4. His hits decreased by 16. He did increase his home runs by 3. He decreased his RBIs by 1, and his batting average went down. The only batting average that went up is .021, which is Barry Bonds. Now, I don't know if this was Barry Bonds' pre-steroid investigation or post-steroid investigation. Not really sure. So, I'm not real sure. So, this is how it could be used in real life. Okay, so we have that. Okay, now let's look at multiplying. And again, you can rewind that and play it back as much as you need to. In matrix algebra, a real number is often called a scalar. So if you just have a number, it's called a scalar. To multiply a matrix by a scalar, you multiply each element in the matrix by that scalar. Okay, so if my problem were 4 times -2, 0 in row 1, 4, -1. The 4 out front is the scalar. And the way I teach scalars, just do distributive property. So you multiply each of these things by that 4. Okay? So what you're going to get, 4 times -2 is -8, 4 times 0 is 0, 4 times 4 is 16, and 4 times -1 is -4. Scalar multiplication. So easy. Now, let's put some things together. Okay? So, let's say we have -2, then we have parentheses, then we have 1, -2, then second row 0, 3, plus -4, 5 on the first row, 6, -8 on the second row. Now, one thing you need to remember is that order of operations applies. So we're going to start in parentheses. Okay, so when we start in the parentheses, what we're going to get here, we're adding 1 and -4 is -3. -2 and 5 is 3. 0 and 6 is 6. 3 and -8 is -5. Now what we have left is this -2 that's out front. So now we do our scalar multiplication. So this is going to give me a +6, a -6, a -12, and a +10. So just do order of operations. Super, super simple. All right. Let's do a different one. Let's say that matrix A is a 2 by 2, first row being 2, 3, second row being -1, 0, and B is a 2 by 2, which is -2, 1, 0, -1. And then they tell me for this problem, they say find 4A minus 3B. So, what does that translate into? Well, it translates into 4 times the A minus 3, then we stick in the B. Okay, so order of operations tells me that I do multiplication before I do addition and subtraction, and I do multiplication from left to right. So I'm going to multiply these things first. So this one's going to be 8, 12, -4, 0. Okay. Then you can multiply by the 3. Now, if you multiply by -3, then this would become addition in here. So I'm just going to multiply by the 3. 3 times -2 is -6. This is 3, 0, -3. Now we do our subtraction. So when I do the subtraction, 8 minus a negative, so this changes this to a positive, so that is now 14. 12 minus 3 is 9. Negative 4 minus 0 is negative 4. 0 minus negative 3, so that changes that to a positive 3. So that will be 3. And that, my friends, is my answer. Let's do another application base. Sorry, the print's a little funny. Map reads on the side of a cereal box that each ounce of cereal contains the following percentages of the minimum daily requirements of vitamin A is 25%, vitamin C is 25%, vitamin D is 10%. If Matt eats 3 ounces of cereal for breakfast, what percentages of each vitamin will he get? Show the matrices and the matrix operation involved in your calculation. Label your matrices. Okay, so he's eating 3 ounces of cereal. So this one is vitamin A, vitamin C, vitamin D. This is 3 ounces of cereal. So when I multiply that, I'm going to get 75, 75, and 30. Now, remember these are percentages. So, if we leave this in matrix form, that's vitamin A, vitamin C, vitamin D. Okay, and there you go. All right, last problem. The regents at a state university recently announced a 7% raise of tuition rates per semester hour. That happens all the time. Current rates per semester hour are shown in the following table. Okay, so technically speaking, we could write and label a matrix. So let's make this part A. Okay, there's our matrix. Find a new matrix that represents the tuition rates per semester after the 7% raise goes into effect. So, for part B, we would do 0.07 times the 75, 0.07 times the 204, 0.07 times the 99.25, 0.07 times the 245.25. Now, we get out our calculator. We do 0.07 times 75. We get 525. Okay, so that's how much it increased. And then the 99.25 times 0.07, this is going to be 6.95. Okay, because it's money. That's how much it's increasing. This is our increase in rates. And this is undergrad and this is grad. This is resident, and this is non-resident. So like in-state, out-of-state. Okay, so 204 times 0.07 is 1428. And 245.25 times 0.07 is 17.17. Okay, so that's how much it's going up. So now it wants to know what the tuition is going to be. So that's the first part. So the second part is taking the old tuition and add the increased tuition. Okay, so this is going to give us 75 plus 525 is 8025. 99.25 and 6.95 is 106.20. This one's 218.28, and this is 262.42. Okay, and it says that we should label it. So this is undergrad and grad, resident, non-resident. Okay, then part C says find a matrix that represents the dollar increase. So that's the thing we found just a few minutes ago. So that won't be hard. So the 525, the 695, 1428, and the 1717. And again, this is undergrad, grad, resident, non-resident. Okay. And there you go. If you have any questions, please let me know. Have a great day.